First thing I would like to highlight to you is please highlight. Remember, first thing you look at the question, sometimes they write for you the diagram, sometimes they don't. But is this a multiple event or single event thing? What is the keyword here? Single event or double event or more? Takes two balls, one after another. How many things are you taking here? Actually, by right, total 2, right? But actually, it's a double event. You must assume that I'm going to take one ball first, and then a second ball. So this is a double event. It's a 2 event thing. Okay. Hence, you have a tree diagram where your first event is what will be my first ball, and then what will be my second ball. Okay, then in terms of outcome, which they never write, let's fill it in so that it give you a better idea. This outcome, the first one is that if I take a red for the first one and take a second red. Second one should be red and then blue. Blue then red. These are the different realities or different outcomes. Okay, then we start to fill in all the blanks there. If this is 4/5, this one must be 1/5 lah, because add up to 1. Okay, this one is quite the simple part. If this is 3/4, this one must be 1/4. Then this one 2 blanks. Then you think very carefully, how do I get this? Now, tricky part. When I say one after another, actually you think about it. This is what we call a without replacement case. What do I mean by this? Let's take a look at the blue case. So in this reality, I had taken a blue in the first event already, right? So how many blues are left? No more blue, right? 0, right? So actually, there's no way I can take another blue, right? If I already took a blue. Then the other one actually by right is 4 out of 4, which is 1. So confirm I will take a red if I had taken a blue first. Make sense? So with this, you can answer any of the questions there. Move down. So, B part 1. What is the probability that I take 2 red balls? Can you see I write RR is exactly this outcome over here? Agreed? So what's the probability of it happening? I must take a red and then I must take another red. So therefore it is, I must take my first red and then I must take my second red. 4/5 times 3/4. Make sense? Which is 3/5, that's all. Okay, comes the second one, which is the loaded statement. Okay, don't jump to any conclusion. I just say I want 1 ball of each color. So I look at my outcomes. Which outcomes satisfy that statement? 1 ball of each color. This one or this one, right? Did they tell you which one comes first? Did I say I must take the blue ball first? They never say. So it could be red and then blue or blue and then red. Both these satisfy this statement. Hence, in terms of calculation, it is red and then blue. So red is 4/5 and then blue 1/4 or plus blue then red. So 1/5 and then red 4/4, which is 1. And then you just add them up. Do you see how this is going? You draw the tree diagram out, you see very clearly all the possibilities that can happen, and then you multiply and add them up accordingly. So this is the proper way to do any of the multiple event questions from here on, which gives us 2/5. I won't write the, sorry. Blue, 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 yellow, yellow, red, yellow, blue, yellow, yellow. Okay? This will give you a bird's eye view of what you need to answer the questions later on. So anyway, I've answered all A already, just by using the idea of within the branches, they all add up to 1. Oops. So now I'll answer on the right hand side. The questions there. So B. What is the probability that both marbles are of the same color? So guys, this one is English lesson also. Hey Adam, please. Probability that at the end when I take two marbles, they are both same color. Is there one outcome that satisfies this, or is there multiple outcome? Multiple, so it's a loaded statement. So it could be, now I write out in English and practice the and and the or part. It could be that it is first one, red and then red. Agreed? Same color. Or plus, what is it? Next one could be what? Blue lah. Or it could be yellow. So do you see the benefit of writing out all the outcomes here? You can see it very clearly. And then what comes next is just going along the branch and then get the answer. So remember, n is times, or is plus. So red and then red. So what's the, look at the branch there. First red is 8/18. And then, so times and the second red which is there, which we filled up, 7/17. So that's the probability for red. Okay, pretty straightforward. Next one, I look at the branch of blue. So plus 6/18, and then the second blue is 5/17. Okay, I'm literally just following the branch there. That's it. So if your calculation or your tree is nicely written out, you can answer any question. Last one, yellow. 4/18, 2/9, doesn't matter, times 3/17. Then after that, it's just you and your calculator lah. William, you follow? Yeah, this one should be okay. So I will get not a nice number of 49/153. Right, now everyone, on your paper, can you circle C? Circle question C. And now you answer my question first before you answer this one. So now they ask you, what is the probability that both marbles are of different colors? Right? Okay? And I look at all the outcomes. I think you can eyeball and tell me all the different outcomes that satisfy this statement, right? For example, got yellow, blue, right? Yellow, red, different color, right? And you can count. My question is there a faster way of finding out all these things rather than this one plus this one plus this one plus that one?
Yes. 153 minus
153 minus? Why do you say so?
because 49 is for the same color, so 1 is obviously.
Okay, so now you think about it in totality. I'm picking two balls, right? Think of it black and white. It's either I take both same color, if not, it must be what else? Different color, right? So both these statements make up a lot of probabilities, right? But at the end of the day, these are all the outcomes already. So you could do hard work, everyone. Different color. Add. But then you realize it's just the opposite of the first one, which is everything same color. So I take my total probability of 1 minus away the probability that they are actually the same color lah. You understand? Because same color plus different color adds up to all your probabilities. So this is shortcut. That's why I ask you to circle. Next time you can refer to this. So this is a trick you can use for some questions only. Some only. When you are sure that the other answer and this answer adds up to everything, then you can do this. So this one is just 1 minus 49/153, like what Adam was trying to say. So basically that's 104/153. Okay? But then you know lah, in the exam you kanchiong, you just want to add everything up, you also can get lah. Okay? But you might make a calculation error lah, because this one times that one slowly right, you use up a lot of space. Okay? D. 1 red and 1 yellow. So I write down in English, 1 red, 1 yellow. How many outcomes satisfy this statement? Sorry? Not just one only. Two, because they never tell you which one come first, right? When I pick, it could be red and then yellow, or yellow then red. You don't know. They just say, just at the end, just give me one yellow, one red can already. So you just go and add this up. Can you do this on your own very quickly? Okay, so I will write the in between. Make sure you can get that. If I were to write E in a statement, probability that two boys or two experiments have blue and then blue. Okay? Can you tell me how will I write the next part? How would this look like? Why divide by 2? Why divide by 2? Average. Why do you say it's average? Let's think very carefully. Let's use it in English. Two boys both have blue, right? If I'm one boy, right, and to get blue, what must happen? I must pick blue, and then I pick blue. I'm number one boy, okay? I pick blue and I pick blue. This is only half the experiment. What must happen also to satisfy the statement? The other one also must get blue and blue, right? So I say again, you think very carefully, is I'm the first boy, I blue, blue, and then blue, and then the other guy also must blue and then blue. So are you sure it's going to divide by 2? Yes, it's one boy gets blue, and the other boy also gets blue. Correct? Then everyone also get blue. So I keep on stressing on the English that I'm using here, right? To satisfy this statement, first boy must blue and then blue, right? And then also the other side, you must have blue and then blue. So in total, actually what we're looking at is 6/18 times 5/17 for sure, right? One blue. It must happen twice. In other words, it's squared. Let me ask you, half times half, you get bigger or smaller? Agreed? So if I confuse you with a square, never mind, I don't write square. It's basically times 6/18 times 5/17 again, which is, that's why it's a square. I'm multiplying by itself again. So, first boy blue, and then the second boy also must blue and blue. Because for this thing to happen, many chances had to happen at the same time. Blue and then blue on my side, and also the other side must have blue and blue. So it's exactly like what Adam was telling me. It's actually getting smaller and smaller. Every time I multiply by another fraction, the number actually gets slimmer and slimmer, smaller and smaller. Just like half times half, if you keep on multiplying by half, actually the final result is getting smaller and smaller. Okay, so finally the end result is a 25/2601. Now, you tell me, is this very slim chance or high chance? It's a very small number, actually, if you change it to decimal. Okay?